So we are not starting measurement, but we're moving from the measurement, we're moving to the measurement part of grade 10. So in grade 9, and you have worked on that at the end of last term, you should have done exercise 1 and 2, where you calculated surface area and volume of rectangular prisms, of cylinders, and I think that was it, okay? So now we're adding our new shapes, okay? So the first group of shapes are right pyramids, okay? What is a pyramid? The pyramid will have a base, okay? That will be the base, okay? And you will have an apex, okay? So when we spoke about, what do you call it? Prisms, okay? A shape, prisms, it always had a base and a top, and they were identical. Okay, but now we have an apex. Okay? Now we can have a square pyramid. Okay? Or let's put it this way. Every pyramid has some kind of a shape at the bottom, which we call the polygon. Okay? It could be a triangle, a square, or a hexagon, or whatever, and then an apex. So if it's a square, it's going to be called a square pyramid. Okay? A square pyramid. If it's the base is a triangle, it will be called triangle pyramid. Okay? And the pyramids we're working with, their base are always equilateral. That means all the sides are the same. And the other thing that they all have in common, they're called right pyramids, which mean, okay, if you take the middle, the center of the base, okay, and you take a line which is towards the apex. So you put a line from the apex to the center of the base. That line will be right angle to the base. Okay? That doesn't always have to be, but it's always going to be the case with the shapes we're working on, and that's why they're called right angles. Okay, because that's a right angle. Same thing here. Okay. Now, how are we calculating volume and surface area? Well, the surface area, SA or S, is basically just calculating the area of each one of the shapes that we have. So we have 1, 2, I should really draw the other triangles here. Okay. So we're going to have 1, 2, 3, 4. You can see 4 little triangles, okay, which are all the same. We're going to calculate the area of 1 times by 4, and the area of the base at the bottom. Over here, we only have 1, 2, and 3 triangles. Calculate the area of each one of them. I'm not going to write formulas for you. You know how to calculate the area of triangle. Add them all up. Add the area of the triangle at the bottom. Okay? So I'm not going to write down a formula for the surface area. That's just, it's not that easy. It's actually quite tedious, but we don't have a formula for that. What I need to give you is the formula for the volume. Okay? Now, if you remember, for a prism, okay, prism, the one where it has base, top and the bottom, then what we do is we time the area of the base, and we timing it by the height. Okay, height is the distance between the two bases. Okay, so that's going to be the area of base, and that's the height. Okay. Now in a pyramid, it's almost the same. The only difference is you have to divide by 3, or you time it by 3. That's the only difference. Okay? So the difference between a pyramid and a prism is that you have to time the area of the base by the height, and you time all that by 3. Okay? Just remember, it kind of, I don't know if it makes sense, but you know, if you replace that base with an apex, then obviously the volume becomes smaller. Okay? How much smaller? It's a third smaller. Okay? Right, let's move on to a sphere. Okay, a sphere is just like a ball. Any kind of a ball is a sphere. Okay? Alright, it will have a radius, okay, we call it R, okay? But that R is not just the distance between this point and all these points on that circle, it's the distance from this point and any bit on the surface of the sphere. You understand what I'm saying, yeah? Now, here you've got completely different new bunch of formulas that you haven't come across before. So the surface area, okay, surface area, so we call it, they use S for surface area. No, they use A, so I'll use A, not S. A for area, okay? A for surface area. Okay? So the area, or the surface area, is 4 pi r squared.
So can't you just do SA because
I can do SA. Is that better?
Yeah.
That's what I normally do for grade 9. Okay? Surface area. SA is 4 pi r squared. Okay? You know pi r squared. What is pi r squared? Area of a circle. So then just add a 4, and then that's the area of the sphere. You understand the difference between the area of a sphere and area of a circle? That's the area of a circle. But we're looking for the whole area of the sphere. Now, like if it was an orange, we're looking at how much orange peel you have. Does that make sense?
Yes, sir.
Cool. Now, V, the volume, is 4 over 3 pi r cubed. Okay, you just got to remember it. I'll be honest with you, I think that at the end of matric you will get these formulas when you do a matric exam, but I would really recommend you to remember it, or to kind of have a feeling of what it is. Okay? Okay, that's done. Last thing, we've got the cone. Okay? Can I see it on the camera? I can. Right, so cone, you understand what I'm saying when I'm saying cone. It's kind of like a pyramid, but instead, because why is it kind of like a pyramid? Because I have an apex and I've got a base. But the only difference is that I don't have a polygon here, and the base is not a polygon, the base is a circle. And therefore I don't have these triangles. It's, you know what I'm saying when I say cone, yeah. Right, okay, so I need to calculate area. So the area, we said SA, the surface area, there's 2 parts for it, you can see. You've got the circle at the bottom, okay? And you've got that thing around, okay? So it's going to be the area of the circle, pi r squared. Okay? And here you have to be a bit careful, depends on the question. Maybe you might have a cone, like an ice cream cone. And the ice cream cone actually doesn't have the base. Right, it's just that big, so you might not include that one. So you have to watch out what they're asking you. So it's going to be pi r squared plus pi r l. What does L stand for? What do you reckon? Just guess. The what? Sorry.
The length of the
Okay, so actually no. Okay, that's a good guess. Okay, so that the height will be here, but the L in fact is this distance, is this diagonal. Okay, so from here to here, that's your L. Okay, that's your L. Alright, and the volume, okay, volume is exactly the same formula we had here. So remember, to calculate volume of a cylinder, for example, you take the area of the base, time it by the height. So what will be the area of the base is pi. Write it down here. Pi r squared, time it by the height. So this is going to be the h. Give it a different color. Okay, so this is your height. Okay. By the way, the cones we're going to be working with are also right cones. So the line from the apex to the base, to the center of the base, hits it with 90 degrees. So this is h. Okay. The volume is going to be pi r squared h. That will be the air volume of a cylinder. But now what do you reckon we need to time it by? To calculate the volume of the cone? If this is the volume of a cylinder, right, when we have a base, the top and the bottom, pi r squared times h, what do you have to time it by now? Pi r squared. Okay. Yeah.